Hey everybody, thank you so much for joining. I really appreciate it. My name is David Awad. I am one of the many wonderful developer evangelists at R3 working on Corda. I'm here to talk to you guys today about the Corda accounts. So we're just going to give it a little bit of time to get started here. I want to give it, I want to say, a minute or two just for people to join in. That should be fun. We're going to talk basically about the different things that we've been building out with the Corda accounts features. We're going to show you a little bit about how it works. We'll also do a quick recap of how Corda works for those of you who have not been at some of our earlier boot camps that we've been doing. We've been doing kind of a series of them over the past month. So that being said, I would like to start actually with a quick poll, if we could, just to kind of get a sense of your guys' experience levels. Just post, if you could, your expertise with Corda, just from a scale of 1 to 5, 1 being not at all experienced with Corda, and 5 being experienced. We just want to get a sense who are we kind of talking to so that we can better fit our content and get a sense of who's jumping in to talk with us, and we can kind of take that into consideration with future boot camps and things. So if you could just post in the YouTube chat 1, 2, 3, 4, or 5 for very experienced, just so we can get a sense of what's happening. Worth mentioning also, my colleague Peter will be in the chat box. So if you guys have any questions, feel free to post them. Peter will be able to take them for you and help you guys out. All right, so that's 2 minutes. I think I'll take it from there and just get started. So, like I said, we're going to talk about Corda accounts, but we'll start with a quick recap of just how the Corda blockchain kind of works, some critical abstractions to keep in mind when you're building. So, long story short, when you are representing objects on a blockchain using Corda, you want to have 3 key abstractions in mind. Those are states, contracts, and flows. So states, long story short, are the objects that you want to represent on the and maintain on the blockchain. Right? States are objects, essentially Java classes that get consumed, updated, or stored. Right? You can create loans, you can create tokens, etc., and they can be modified with time, so they can be issued. Right? The classic idea of an object, anything that you can represent in a programming language class can be a state. Contracts verify the transactions that you can do with those states. For example, one contract command might be to issue a loan, or to manufacture a car, or to sell a car. It might be a different contract command or a different thing you can do with that object. And so we have contracts that embed a series of rules that outline the validity of a particular type of transaction. So keep that in mind. Those are what contracts do, right? Contracts are the things you can do with your objects or with your states. Lastly, there are flows. So flows are the tool by which you execute transactions or cause changes on the blockchain. So in this example, we have node A, node B, and a notary pool, where essentially node A, in our previous examples, has a single account on node A, or rather a single party that operates through node A, and we'll talk more about what we mean by that in a little bit. Node A proposes updates, it checks them, it signs them, and then it sends it out. So a flow is kind of the entire process of a ledger update. So when node A runs its flow, let's say that is to pay some money on a loan that node A has to node B. So node A will run the flow that performs a contract command update or pay, whatever you want to call it, to change the balance on a loan. And so if I'm going to change the balance on a loan, my flow needs to perform the communication of my Corda node talking to your Corda node, having that transaction update verified by the notary, and then coming back to me so that I write it down in my notebook, you write it down in your notebook, and we're all good, and we can't update it after that without going through the same process. So again, objects objects are the things themselves. Contracts outline what actions can be performed on those things, and flows are the way by which you actually perform those updates. So that's our quick recap there. Hopefully all of that makes sense. Again, Peter's in the chat. I guess that is down there. You should be able to find him without any issues. So hopefully that quick recap makes sense, and then we'll jump into the actual features here with accounts. So in this model I just gave you, I talked to you about node A and node B. Maybe that could be me, David Awad, the individual, and node B can be Bancorp Bank, right? And so normally when people use Corda, you have a single node that represents a single entity, or perhaps you could say a single party to a transaction. And so one of the opportunities we see with Corda accounts is that you can actually have multiple accounts on a single node that can sign transactions. And so the opportunities we see here is that if you can have multiple multiple accounts on the same node, you can do a lot more with that singular node. And we'll get much more rigorous about what I mean by this in a little bit. But this idea, just to kind of get us started, is that you can have distributed systems that can be deployed and operated by individuals and small businesses, such as a local candy store or our good friend of the DevRel team, Roger, who maybe runs his own Corda node, something like that. You can have multiple entities represented on a single Corda node without having to run separate nodes for each entity you want to have representation for on your Corda node or within your Corda transactions. So this is really nice because now you don't have to spin up a distributed identity for every single customer, especially as the number of customers goes up, right? We also see some great opportunities for existing customers, right? It's less total cost. And we see huge opportunities in scalability, right? You now can spin up 1 or 2 Corda nodes for 1,000 customers or something like that. If you're currently a Corda customer and want to support, let's say, if you have a supply chain model where you have multiple manufacturers that you want to use Corda to track transactions with, but don't want to have to spin up 1,000 Corda nodes, right? So you can kind of start to see intuitively how this can get really useful, not just on the single person wanting to represent many entities on a Corda node that are all different. You could also do this for a single Corda node for a single company. Let's say that Bancorp Bank wants to have a single Corda account for their marketing department to sign transactions, and that can be separate from their legal department, who might want to sign different transactions. So I'm sure you'll come up with different use cases, and we'll be curious to hear about them as we go, and maybe after this you can tell us your ideas. But that's sort of the basics that we imagine when we think about this. So let's get a little bit more rigorous here. So it's called Corda Accounts Library. Long story short, the Accounts SDK allows a Corda node operator to split the regular vault of facts or states into multiple separate logical subvaults. Note that I said logical, not physical, and I'll elaborate more on that in a minute. But just keep in mind this normal network you could imagine, right? There are 3 parties, and there is an identity manager there. But each of the nodes are currently separate. And in the previous way of thinking about this, a single node corresponded to a single party. And now look what happens when I include the ability of having accounts, right? Now you have multiple different key pairs to sign transactions within a single node, which can be really nice. So that's where that idea comes in. You can have, let's say, marketing, legal, accounting, etc., which can be really nice. So with the Corda library, you can create accounts that are hosted by these existing nodes. So this is really nice. Hopefully you're starting to see what we've achieved, which is kind of bypassing one of the very common limitations of many distributed ledger technologies, which is that each node can only represent one entity. So you can kind of see how that comes out on the other side, right? That you can have accounts that are shared between different nodes that can represent identities to make it easier for you to deal with them, interact with them, manage them, create transactions between them. And so I want to show you guys what the vault itself might look like on the other side of this. So here's kind of a pictorial explanation, right? Imagine you are a single Corda node where now you can have normal party level shared facts. Let's say if you are Bancorp Bank, then here are maybe your private facts that are not necessarily associated with an account. This is stuff you might do as a company yourself. Let's say Bancorp Bank is a publicly traded company. These might be your information that you're using in your SEC 10K filings. And so you will have these at the abstraction level of the company, but then account one could be your marketing department's transactions with another party that is them paying invoices for marketing software or whatever it is. Account two could be your legal department, etc. And so each of them has its own sort of key pair for an account, or whether it is account one on node A, account two on node A, or account X on node B. The different identities are mapped to different key pairs and account IDs. So this kind of basic level within the Corda vault has all of the facts, and they are kind of tagged and isolated with this notion of which account they're a part of. And then we have an identity service that the Corda node maintains that actually maps each key pair to the particular account. And then at the key management service level, we just have all of the key pairs, so you can figure that out. So this is sort of exactly what goes on in the database when you utilize the accounts library in your CorDapp. The design data block will be tagged with accounts, and again, those accounts are just hashes and user IDs that can be tagged on your data block. And if this is seeming confusing, we're going to jump into the source code in a little bit. So don't worry if you're losing me, but I'll show you where all of this lives, and you can kind of see how it's used with the code example in a bit. So again, that key management service just manages the storage of public and private key pairs, and the identity service just manages the mappings between the keys and the account information. So in summary, utilizing accounts can be just as simple as tagging the block data with an additional tag, right? And that'll help you better filter and find your query data when you want to do so in the future. All right, let me just grab some water. So it's important to note, accounts are not the same thing as Corda identities. They're a different representation of a collection of states and public keys, right? Accounts in the node are not equipped with X500 names. They are not automatically discoverable by the other nodes the same way that Corda identities are, and it is not listed in the network parameters file, for those of you who are a little more familiar with Corda, right? All of the accounts operations are implemented at the CorDapp level. So keep that in mind, right? All of the accounts operations are at the CorDapp level, and they are not automatically discovered by the other nodes in the network. And one other important caveat to keep in mind, physical vault isolation is not supported. All accounts information and keys are in fact stored at the same key management service of the hosted node. The node operator will have all of that information. If you, at the end of the day, all of the data is stored in that singular node's database with respect to the different accounts being used. If you are using standalone hardware security modules, private and public key management is currently not supported, but we are actually doing research to figure out whether it's possible for us to make that work. So we will definitely be very loud about it if we're able to make it happen. So keep your eyes peeled for that. But those are the only important notes I just want to make clear so that you guys don't have the wrong idea about what we're going to do here. So I've laid out a whole lot of information, and just to bring this home, one or two more slides before I can show you guys the code. But what this gets you is, now imagine there is node A, node B, and node C. You have the ability to do these transactions between your accounts inside of node A and regular nodes You can have account to node transactions, right? My marketing department can in fact go and talk and make transactions with another party using Corda. And my accounts within my company or within my organization can also perform transactions with other Corda accounts. And my accounts can perform transactions with accounts on other nodes, which is really nice. So we're giving you a whole lot of granularity that you can now use for your Corda transactions. So hopefully now it's all coming together. The use cases, as I'm sure you can start to see, are endless, right? There's great examples of kind of custodianship accounts applications. If you're a bank account or you're a brokerage or something like that, and you want to simply have a singular Corda account for each let's say customer using your brokerage. Any applications that involve multiple teams in a large company, you can isolate sensitive information from unrelated departments. You can create massive business to consumer applications where nodes can represent millions of customers. So the kind of key that we're driving here is really about scalability, right? That's what it's all about. We're giving you the ability to scale the use cases that you can get out of singular CorDapps. So let's get under the hood a little bit. There's two or three kind of things we're going to touch on just to give you a familiarity of how we use this relative to normal CorDapps. So that's the account info and account service structures or abstractions, I should say, and the flow of accounts in a CorDapp. So the account info is essentially the Corda state that stores account information. And then there is, of course, account service, the interface that consists of account-related methods, and I'll show you that in a little bit. Without further ado, I'll jump into IntelliJ so you guys can see what I'm really talking about here. So let me jump into IntelliJ. I have a lot going on here. So we'll start with account info right up here. So inside of account info.kotlin, inside of here, we essentially see what you'd expect, right? Each account essentially has a string, which is the name of that particular account. Let's say it's marketing department, a unique identifier, and then the party, that is the actual node, the Corda node that account lives on. And so it's not surprising then that you have the ability to call gets just to get a list of the abstract parties it's involved in, some persistent account info, and a unique identifier. You also can get the supported schemas and a few other things. That's the long and short of it, right? And account info is nothing magical. It is just a tag that you can attach on top of a set of keys that will be managed for you for your transactions. So that's why there's not much going on here, and you'll see that here. So the app property name, right? String name for the account, and then the party, a Corda node, and the identifier. Then on the other side of it, right inside of token issuance flow, you will see inside of get account service, inside of utilities, there is account service.kotlin. And in here, you will see a whole lot of different things that it can do for you. You'll see in the code a much larger explanation of what's happening here. By the way, just so you can see the code that I'm talking about, this token issuance flow, which we'll get into in a minute, I would recommend checking out the samples Java/accounts bootcamp. There's a branch for that. So inside of account service, we have some of the similar abstractions you'd expect. The account service tells you what are the accounts we have. It performs a vault query. If you would run this from the perspective of your own node, right? What are the accounts on my host? Let me create an account. Let me find the keys for a particular ID. Let me find the account ID for a particular key. Let me find some account information using either the owning key or the user ID, and then account info. So you can kind of start to see a lot of the kind of getters you'd expect to find when you're using this. And we'll see this in context in just a minute. So again, when we described earlier how this logic plays out, normally when you're in the context of building a CorDapp, you have that abstraction, states, contracts, flows, right? I want to show you what happens prior to initiating a flow. what happens within the flow, and then we'll talk about how you get your data after the fact. So prior to initiating a flow, of course, you have to create an account that you want to use for this, and you have to actually share that account with the counterparty that you're going to create a transaction with. So let's start with that. If you look over here, inside of create and share account flow.java, you will find a few things that happen. So you would run this flow from your own Corda node where you are going to pass the name to create your Corda account, and then it will be shared out. Now we have this flow does both. It creates and shares. It's called create and share account flow. It does exactly what you expect. It creates and shares an account. So the arguments to this flow, pretty straightforward. The account name, which is the name of the new account. Let's say it's marketing. And then the party to share that account to. And this is just this is literally just the name of the other party that's supposed to get this information. And then, of course, when we run the flow, we get back a state and ref to the result of the subflow, which is just a call to create account, which we saw over in the account service. And we just pass the account name. Once we have that state ref, then we can use it and call share account info and share the account information with the other party that we want our marketing department to be able to create transactions with. So hopefully that makes sense. And by the end of this flow, we have created an account. We've done the groundwork to be able to use our new Corda account when making transactions. So on the other side of it, the next piece of what we need to do here during the flow, and I'm gonna get a little wordy here. First, we're going to self-request a signing key for ourselves, and then request a signing key from the other counterparty's account, right? We're doing this because when we utilize account features, you want to make sure to create a new set of public and private keys for each transaction. The reason we would do that is because when your counterparty decides to transact with you, the output states that are generated by the current transaction involving you and that other party, meaning by that I mean your account keys and their account keys are both signing keys on the transaction. When the output states are generated, if they ever go to a third person, you want to make sure that your public key is properly masked so that that third person who has nothing to do with the two of you is not able to see any of the information about your transactions or your specific public key. So it's a nice little privacy thing that we make sure of. So that's why you want to create new public and private keys for each transaction that you're doing when using accounts. So the next thing you're going to do, you're going to set the account keys as state participants because this is what indicates who stores the states during this transaction, right? Then you're going to self-sign the transaction with the account key. Depending on the use case, the host node can also add their signature. So if it's marketing department at Bank Corp, both marketing and the Bank Corp itself can both sign that transaction. Depends on you and how much information you want to add. Then, of course, just like a normal Corda flow, you're going to sign it yourself. You're going to give it to the other person. They'll sign it, give it back to you. The normal kind of collect signatures behavior that you may be used to if you've written CorDapps before. So we collect our signatures from our counterparties' accounts, and we finalize the transaction. So the real differences are really just going to be around specifying the account and making sure we use the right public and private keys to sign the transaction. So since we've now kind of endorsed the accounts, we have to be really careful when we do queries. So I'll show you what I mean in a second. But first, let's take a look at IntelliJ, and I'll show you how this flow kind of plays out. So here's an example of a token issuance flow. Those of you who were with us at the last bootcamp probably remember this. It's a very simple flow. What it does is it is someone issuing a token to somebody else. So the state has an issuer, an owner, and an amount, 2 strings and an integer, nothing surprising. So when the flow runs, of course, we need the issuer and the owner and the amount. And at this point, we do a little bit of magic with our accounts that will look different from the previous bootcamp if you were there. So of course, the first thing we do is we actually get the accounts themselves. We get the issuer's account info and we get the owner's account info, and we use the get account service to do that. We get the account info and the information for both the issuer and the owner, right? In this flow example, we are performing an outward issuance of a token to another party, or in this case, another account, right? And so we start by creating some anonymous parties for the two accounts, using some subflows to request the keys for the accounts for the issuer and the owner. We then create our flow session, and we grab, just as normal, we get a reference to the notary that we would use in any other Corda transaction. Then we go and start building our transaction itself using that notary reference. We get the token state just like we normally would. We create a new token state object that contains the issuer and the owner and the amount. Note here that we are actually passing the issuer account and owner account, and not just the normal actual party objects, but the account objects. Then we go ahead and we go ahead and continue building the transaction. We specify that the output is going to be this token we are issuing throughout this flow. Then on the next piece of it, we add the command. In this case, it is the contract command to issue the token. That is the only one we've implemented. And then we will pass in the owning keys of the two parties that are going to be in this transaction. I should have said accounts there, but you're kind of starting to see the lines get a little bit blurred. So next piece of the process, we of course will ask the service hub to begin the process of verifying our transaction. We'll sign the transaction ourselves, and then we will call collect signatures flow to get the signature from the owner by specifying with the issuer key to tell collect signatures flow that the issuer has already signed the transaction. Once we've done with that, then we will call finality flow to kind of wrap up the process using the typical finality flow that we normally do. So again, the only thing worth mentioning up here, just be aware we're using the issuer account.get owning key and not the usual way you would do it by using the party objects, because these are accounts within the Corda node. So you can start to see those small little nuances and changes in the method calls that you're going to make. And then if this has all run successfully, then we will have our one token state issued to owner from issuer with amount, transaction ID, and there we go. And of course, on the responder side, token issuance flow responder, nothing crazy going on there. The usual stuff that you would see in a responder flow. It uses Corda subflows to simply receive it, and we don't add any custom logic here just because this is a simple little demo for us. So hopefully that's starting to make sense, and you can see the small nuances in how we change the process of specifying the accounts and signing the transaction when we are running a usual Corda flow. And then the last piece is our data retrieval, right? So obviously we now have to be very careful when we perform queries, because now we have this logical segmentation among accounts in Corda on the other side. So long story short, when we do data retrieval, since we now have this concept of accounts, each account-specific query has to be strictly defined by query criteria. Again, this is because all states technically live together, right? The developers have to actually define the account query criteria in the CorDapp. Otherwise, a generic query will just get all of the states. So it is incumbent on you, the developer, to make sure that you are querying for the right thing. So I'll show you an example of what I'm talking about. If you look inside of query by account, you will see that we do a few different things here. When this account query runs, again, this is the node. You are running this on your own node. This is Bancorp that maybe wants to query for all of the transactions in the marketing department. So when we run the flow, you'll see this string, who am I, that's passed here. And this is actually the name of the account on the node where the flow is being called. So then when we call the flow, we're going to get an account info object that will use the account service and pass in the string passed to the flow marketing to the account info. You will get back the actual account info object for marketing, assuming you created it. And then you can, in this example, get an ID just by calling myaccount.getIdentifier.getID. Then you can construct your vault query criteria and just use the external IDs that you just got, as long as you pass them in an array. And then you can actually get the token list, again, just using the service hub and querying by the criteria we just created with that account ID. And then within this if statement, you'll just see some examples of how you'll get access to the correct party objects, and then just giving you the ability to actually look through the particular transactions that come back when you run your vault query. So the majority of the differences really are here when it comes to getting the token list. And once you get your token list back, as long as it's the right size, you can look through it and examine everything that you need to find. And this is all stuff you've hopefully seen before. You'll get back this token list and be able to inspect the individual transactions. So again, keep in mind just that the big difference is here. You're just going to be using the account service, calling account info, and passing in that account name. Hopefully all that makes sense. I highly recommend you try it for yourself if all of this seems like stuff you can handle. A few things that I want to point you at, right? The Java and the Kotlin versions of all of our account samples are the same exact applications. You can find them at these links, github.com/corda/samples-java or samples-kotlin /tree/master/accounts. That is this guy right here. I will even stick that in the YouTube chat so you guys can take a look if you are interested. There you go. And one other note, if you wanted to see the code examples I was talking about here, you can go online to the Bootcamp CorDapp. And within here, there should be a branch called accounts that you can try out. There you go. So you should be able to check this out. It's got a lot of really good information and has plenty of stuff for you to try. There's a link to the Bootcamp CorDapp as well within the accounts. That is the code that I was looking at out here. We have plenty of examples of like the basics that we talked about here on there as well. So, and of course, if you're interested in taking a look at the actual source code of Corda accounts, Corda is open source, so you can find it online. And we have 3 different sample apps that I will point you to. The sample apps we talked about up here, the supply chain CorDapp, which mimics a supply chain transaction where the deal is incorporated among different teams in the companies on both sides of the trade. Then there is Tic Tac Thor, made by one of our good friends in the office named Thor. This CorDapp essentially lets you recreate a game of tic-tac-toe. It demonstrates how you can use kind of linear state transactions between cross-node accounts. And then we have a World Cup ticket booking example where we have a demonstration essentially of how you might build a ticket booking system using the accounts library and the Corda token SDK. And again, all of those are in Java and Kotlin. They are all right over here. Supply chain, tic-tac-toe, World Cup ticket booking. That's all fine. So I think that is most of the information. I know that there's going to be a few questions about this, so I just want to jump over one piece around the public and private keys again. So I'll jump back there really quickly. Where'd I go? There we go. So one other thing that I know we tend to get a lot of questions about is this idea of creating a new private and public key on every transaction when you're using accounts. So I just want to go over that one more time just to make it a little bit clearer. So again, what's happening here when you use an account, when I make a transaction with somebody else and we're both using accounts, the output states generated by that transaction involving me and that other person, right? If that state ever goes to a third party, you want to make sure that your public key is properly masked. And so that's how we can make sure that that third party who has nothing to do with us has zero knowledge of us as an account or as a party, and only has knowledge of the actual state or asset themselves on a kind of need to know basis. That's the big idea we're trying to drive forward here. So we want to make sure again that that public key is properly masked, so that third person knows nothing. That is why you want to create new key pairs for every transaction. So again, in every flow, we set the account keys as the state participants. and then we self-sign the transaction with the new account key. And then you do the usual things that you would in your Corda flows. Just try to keep that in mind. Hopefully that makes sense. And Peter's not getting overrun with questions. I can go check and see how he's doing. Looks like we're doing all right. So I believe that is almost everything that I had for you. If you're actually, I would like to ask before I even give you all of the supplemental information and resources, if you could tell us whether you are doing this whether you're a professional developer or whether you're doing this just to learn. We'd love to get some sense of how that looks. So if you could just comment a capital P or a capital L in the chat, that'd be great. And yeah, just comment a capital P or a capital L in the chat if you could, so we know whether you're doing this as a professional or you're just doing this to learn on your own. So a few things I have to plug to tell you guys about. Our last workshop in June is actually going to be next week. We are doing a workshop on the token SDK. Again, just like last time, we're going to run these 4 times each day, 2 p.m. in London, New York, Mumbai, and 10 a.m. Hong Kong. So if you're interested in that, feel free to look on our Twitter. We tweet out all of our events. You can check out the developer training, training.corda.net. You can join our Slack channel to reach myself and Peter whenever you need anything. We are always there, and we run office hours twice a week as well. I recommend checking out the Corda documentation on docs.corda.net. I also recommend taking a look at the GitHub repository. You can find the Corda source code on github.com/Corda. If you ever have questions and you want to email us, myself and Peter and the rest of the DevRel team are available behind devrel@r3.com. We're on Twitter at Corda Blockchain and at Inside R3. Please use all the hashtags, and you can find us on YouTube here where you already are on youtube.com/Corda Blockchain. Please rate and subscribe to our channel and click the little notification bell, and you'll get notifications every time we put out content. So all of that being said, I hope this accounts workshop made sense for you. We will stick around in the chat, and we are always on Slack. So if you have questions about this or any other Corda features or tool sets, please do feel free to reach out to us, and we will be happy to help you. All of that being said, I think that is everything that I have. So I want to thank you guys again. Feel free to find us Twitter, LinkedIn, the internet. We're all there, and we're here for you, and we want to help you guys build interesting things using Corda accounts to scale up your use cases and give you more flexibility under your fingertips for building great blockchain tools. So with that being said, I think we can call it. Thank you guys very much.